What we're going to talk about is how to send out information to other places, how to get information from other places, how to connect to multiple remote places, get some information, and then use that in your apps. So if you remember so far, when we've been making apps according to MVC, we've been getting that information just from our app itself. We've been getting our data in our model itself. We've been saying, all right, I've probably got a class called something like movies, and then here are all the movies. You will never see that all movies thing, or you very rarely see that all movies thing as a way of dealing with data in the wild. You'll almost always be getting it from some other source, whether it's remotely or saved to the device itself. So that's what Unit 3 is about. Are you all excited? Let me show you what we're going to be able to use by the end of the day. My computer would work. So by the end of the day, just like last time we did this, you were able to create an app on day one. Today you're going to be able to hit a remote source of information that we'll commonly call an API and get back a whole bunch of information. For example, or in this example, with information for all the dogs on this thing called Dog API. There's a dog. An API, we'll get into a little later, but we're going to be able to look at all these different remote sources for information, get back the information that we want to use in our apps. This is clearly a bit of a joke site, but let's see what the dog has to say. Dog, top 10 tips for how to unleash your inner alpha, maintain your, okay, these are all dog puns. But we can look at the internet's biggest collection of open source dog pictures. We're going to learn about how all this works. The first thing I'd like you to do is we're going to need a new program for today called Postman. So if you go to getpostman.com, do not buy tickets. It's not what you want to do. Go to Product, get Postman, and download the app. So let's take about 6 minutes to start downloading all that right now. Getpostman.com/products. Hi, Richard. How's it going? We're downloading Postman. What are you doing? We're getting Postman. Wow, isn't it cool? You will need to. While you wait for Postman, you should sign up. While you wait for Postman to download, the chances are we're all downloading at the same time. You're going to need to probably sign up for an account on Postman. Yeah. So on their website, sign up for an account. And select you save information. Do it on. They're already boom. All right, Kevin. If you have Postman downloaded, you should be able to see this, something like this. You should see a screen that at the top has some info.
Here's the unit 2 assessment.
Mm-mm. So up here it says enter request URL. Has anyone ever heard of a URL? What is a URL? A website? Does anyone think a URL is something more than a website?
The address of a World Wide Web page.
The address of a World Wide Web page.
The uniform resource
Yes. A uniform resource locator. A URL is an address somewhere on the web that you can go and find information from. So for example, when I go to apple.com, this is just the example we're going to use, apple.com, I'm going to a URL that is https://www.apple.com. www stands for what? B? The World Wide Web, that's right. The World Wide Web is, it's not the internet itself. I just want to draw that distinction. The World Wide Web is a service that's built on the internet. The internet is all those computers. The World Wide Web is a way that you can access certain information on those computers, such as websites. Has anyone used the World Wide Web before? No? Well, boy, are you in for a great day today. The World Wide Web, does anyone remember what this HTTPS means from maybe their own life or Friday, Kevin? Cool. So HTTPS is a protocol. Has anyone heard that word before? I think my two things that I love and you all might not love are protocols and enums. Is that solid so far? Guys, what happened? It's Monday. We're learning new stuff. This is great. This is all about the internet. All right, everyone stand up. Come on. Come on. Everyone stand up. Come on. Almost there. Almost up. With your feet. Stand with your feet. Stand with your feet on the ground. Extend your legs all the way up.
I don't come across
You do. I promise. Stand up, everyone. Okay. Reach as high as you can in the air. That's right. Check out my armpits. Check out Richard's armpits. Sorry, I didn't mean to call you out. We're very appreciative of sweaty armpits here. Reach up really high. Breathe in really deep. And make a noise. There you go. Okay, have a seat. We're learning about the internet. The internet. So when you go to a web page, it does some stuff here. The hand sanitizer. Yeah, okay. Smells like vodka.
I love it.
Okay. When you go to www.apple.com using the hypertext transfer protocol, the S meaning secure, just a way of securing the signal, you are performing something called a GET request. A GET request. I want you all to remember that. I'm going to write it down. How do you think GET is spelled, Allison? Come on. You can do it. Start cracking up. Okay. It starts with a G. Okay, good. G, E, H.
T.
A GET request. How do you think they came up with that term for a GET request, Ian? That's right, you're getting information. Wow, huh? So that's a GET request. When you are asking for information from the internet, you are performing a GET request. So going to a website is a GET request. So if I go and I look at Postman, it says it's an untitled request. A request is an attempt to get or give information. It's a request, right? Think of it like the actual word. I'm sorry? This is Postman.
Yeah, but like I created a Postman account and that's not what I see.
Why not?
Because it's different.
You don't have to set your preferences and you don't have to invite a team. So there are multiple types of requests. Whoa. Get, post, put, patch, copy, delete, head, options, link, unlink, purge. We're going to only use really the top 5 of these, and really I don't want to use puts. But the most important one for right now is a GET request. Everything you've done with the internet, or pretty much everything you've done with the internet, when you wanted information is a GET request. A web browser, like you see here, interprets the information from your GET request. It says, okay, you wanted a website, and that website, it shows me a bunch of stuff, but actually what I'm getting is this information here. So this is all HTML. Does anyone remember what HTML is? Nima. Give it a try. You got me, okay. Great, hypertext markdown language. This is a markdown language. I gave this away on Friday. Where else have we seen a markdown language of some sort? Eric. In terminal. Not quite. It was actually, okay. Where else have we used a markdown language? Thank you. Eric. When we're, say that again? Let's be a little more specific. We've seen this markdown language. Phoenix, where else have we seen a markdown language though? Maybe what Adam saw in terminal. Where did we create that? Do you remember? So you've also seen it on GitHub, but what was that all reflecting? Actually, yes, again, thank you. A .md file. Damn, you guys are good. My line of questioning is not great. So the stuff you see on GitHub in this .md file is in this other type of markdown language called Markdown. There's one other place that we've seen a Markdown language, and it's super important because it's a whole bunch of stuff happening behind the scenes that we didn't even have to create. Phoenix.
Calling it a markdown but that changes markup.
Markup language. I don't know. I just call everything a markdown language. And I'm probably wrong. In computer text, oh, ew. Oh, ew. Yeah, okay, so let's start over now. When I say mark up, when I say mark down, I've been incorrect so far, basically. .md is markdown, which is a way of annotating things. HTML is a markup language. What a great start to Unit 3. Don't really worry about the difference in those things, but I should definitely start calling it markup. Thank you. We've also seen one other markup language. Let me show you where we've seen that. So if I go ahead and I go, let's say, to my Unit 2. Is it warm in here?
Yes.
I deleted everything. 6.1. Oh, this is getting annoying. Why don't I just do it through here? Check this out. MVC. Do you guys remember MVC? Lecture code. Table view. Cool. Base.lproj, main.storyboard. Oh, the storyboard isn't written in a language called storyboard. Yeah. It's actually in a markup. Damn, what a good start. Your storyboard is written in this language that has these tags you're going to have to get used to, right? This is the scene. This is a view controller. These are tags that are created behind the scenes for you. Neat. The web is made in the same way. A web browser, which is what we're in here, a browser called Chrome, takes that markup, takes that HTML, and converts it into something you can see. Apple's got a new kind of credit card. iPhone XR looks great. You'll make apps for these. What kind of request did we send to get this, Levi? That's right, a GET request. We sent a GET request to some web address somewhere. Let's talk about that web address. If I go to Postman, I send the same request. Postman is not a web browser, but it's an application that we use to perform the same requests we might from a web browser or from a different service. If I hit send here, I'm not going to see apple.com as I saw it in the web browser, but instead, I'm going to see all the HTML. Yes?
Does it have to have the HTTP?
Let's take a look. Let's take a look. I think so. So what we see here when we make a GET request to apple.com is a web page. But again, the internet is not just computers, it's not just phones, it's not just things made for a web browser. It's also stuff like this dog API, where if I go ahead and I type in this web address, dog.ceo/API/breed/image/random, I don't get back a web address. Instead, I get back this thing right here. Does anyone know what this thing right here is called? Marielle? A what? No, it is not a post. Just this thing I see here, the highlighted text. So a post is a type of request that we'll get to. Yeah. It's a JSON. Do you know what JSON stands for? July, September, October. Did you forget August? Okay. Just like what kind of, is that a helpful heuristic for forgetting August? JavaScript object notation. So, the web. Yes, Olympia, no problem. This thing is an object. It's a JSON object. JSON means the format called JavaScript object notation. You're welcome. Information on the internet, when we don't want to be sending web pages, but instead want to be sending information such as a message and a status, is generally sent, this is the biggest that goes, I'm sorry. It's generally sent in this JSON format. And let's go look at the API's website. This is the internet's biggest collection of open source dog pictures. That's what dog API is. Great. What does this do? Sorry for running ads, but hosting it, who cares? What do you think this request does? It doesn't get us a web page. It does one specific thing. Angela? It gets me a random dog image. Let's see. So in this thing, I've got, oh no, come back. Come back. Let's go back here. In this JSON object, this JavaScript object notation object, I've got something that looks kind of like a dictionary, right? It's got this message, which is a string, and then it's got this long string that looks like it's a file somewhere. And it's got another key called status, which is a string, and then it's got this value that is success, which is also a string. In JSON, this is like a dictionary where you are guaranteed to have keys that are all strings, but the values are not necessarily all strings. You might get integers, you might get arrays, you might get a mixed set of information. I'm going to repeat that because that's so important for what we're going to do this week. Information is sent on the internet, not always through a markup language, not always through HTML. You might be receiving as your result of your GET request, so you asked for some information. The result this time wasn't a website, it was a JSON object. And it's a JSON object with two keys. One is the image location, of a dog. So let's go, let's see if we look that up. Does it send us an image? It does. Nice. So there's our dog. That's the random dog. Thanks so much. It has unsaved changes. That's okay. I'll get over losing that dog. So it's got a key called message that has the location of that dog picture, and then it's got a key called status, which has the string success. Why do you think it includes that word success?
Whenever you call the API, it's going to let you know if it's failed or succeeded.
Yeah. So when I went to this thing called dog API, and I said I want a random dog picture, but let's say I misspelled random, it expects a certain URL. It expects me to send my GET request to a specific place. Random with two M's is not that place. So when I made a bad request, an unsuccessful request, it gave me a status that was error. It was not successful, but instead I was an error. Then it gave me a message for this as well, which said, no route found for get/API/breed/image/random with two M's with code 0, code 404. I don't know. I don't know what any of that stuff means. I'm sure I might soon though. 400s is forbidden. Can you tell us more about that?
Each one with like different accents. So 200s is success. 300s, I forget. 400 is forbidden. It's like a 404 is like forbidden. 500, I want to say it's just it doesn't exist. But we go off the top of my head. Let me actually check. Is it here for that?
No, don't check.
Don't check.
You're not allowed to check. All right. So, this code 404 is wherever we sent our request attempting to tell us something about our request. There are 5 ranges of codes that we get from an API. 100 is what we call informational. It's feedback on the actual status of the request itself. It's not saying, was this a good request? It's saying more, did I receive it? 200 is success. Says the request was successful. So when we got that dog picture, there's a 200 code, not in the JSON object, but if we looked in another section that we'll look at later, see there were 200s. 300 is kind of moved location. So it's a way of saying the request you made, the place you're looking for is actually somewhere else. 400 is client error. 500 is server error. We're going to talk about those in just a bit. Fuck, it's warm. But this is everything we're going to do this unit. You're going to go out and you're going to say, can I have some information? You're going to either get a successful request. Look at all this stuff. Wow. A successful request has a 200 OK code. Standard response for successful HTTP requests. The actual response will depend on the request method used. In a GET, the response will contain an entity corresponding to the requested resource. In a POST request, the response will contain an entity describing or containing the result of the action. Neat. We don't know what a POST request is yet. But we know that what we did before was a GET request that was successful, a 200 code. The body of the request, which you see on this left side, the body of the request got us this JSON object with a message and a status. That is all we're going to be doing as we build new apps. How do you think you could use this in your apps? Tia, let's say you created a dog app. Let's say you were creating an app that was just a list of dogs. How could you make use of this, what we're calling an API, to create that app? Say that again?
I have a question about memory.
Memory.
Yeah. In that scenario that you're talking about with the dog app, then this app would have to be connected to the internet to work, and it's pulling the data from whatever website it's finding it from. This isn't stuff that's stored on the phone itself.
Correct.
Yeah.
That's a great question. So in order for your app to make use of this information, it has to be able to connect to the internet, and then it has to go out and get this information. So this information isn't stored on my phone. Think of your phone interchangeably with a browser. The way they get information is they both go to the internet and they say, can I have this? Or they say, here's some information. And a GET request is that, can I have this? Can I get this thing? And it'll work in the same way as going to a website. So if I were to have my app on my phone go and pick out a random dog picture, all I would have to start is this website, this https:// blah blah, this URL that, again, I'd need service to get, and then all I would have is that string. So I then have to go and get that actual image itself from the internet again.
Does it then get stored on your phone? So, or does your phone have to go into the internet?
That is something that you, the developer, set up, whether you want to store it or not. You can persist this information on your phone. There's a local database that we'll discuss in Unit 4 on how to persist data on your phone. If you don't persist it, then yeah, you have to go out every time you load a view and say, hey, I wanted to load an image from the internet. Can you go and get that? Can you go and get that? Can you go and get that? We're going to talk about how you actually go and get that probably next week. Sorry. But for right now, yeah, if you don't tell your app to save that information, then you're going to have to get it every time. But there are ways to save that information to your phone. Does anyone see how they might use this to make an app they were interested in? Want to tell us about it?
How do you use this to make an app?
Yeah.
Yeah, you have your information that you create all your dogs somewhere. You use get calls to pull the information that you want to show to the user, just like you're saying. So we have an app, a database of dogs, and I'm going to pull a list view of all the dogs. I would get write an API or use an API that pulls all of the names of the dogs in the database. And I would be able to then decide how to format and display that information to the user. The user then wanted to enter a dog into the database, use a post request, and I would fields for them to enter in, say, name of their dog and an image for their dog, and I would send that information into the database and update my database with those files.
Cool. But what app are you going to make?
What app am I going to make?
Yeah, you don't only have to make a dog app. Let me show you. So has anyone heard of Spotify? So Spotify also has an API. You can connect your app to an information set that Spotify gives to you. You need a token. We're not going to get tokens today. But you can go ahead and look at Spotify URIs. What is that? A resource identifier that you can enter? It looks kind of like URL. A URL is a way of finding things on the web. A URI is the path to finding a file in any context. So if I looked at my PWD, let me do that. Show me. My print working directory, it prints out the URI of my working directory in my terminal. In the same way, the path to get to this web API URL is a URI. A URI can also be a file location in your app. It could be that you saved an image or a text file or anything else in Xcode, and you need to know the path to get to it. That's the URI. It's incredibly warm in here. So Spotify lets me look through a whole bunch of things. Let's see. Okay. It looks like their Spotify for developers has a quick start. Create a simple server-side application that accesses user-related data through the Spotify web API. Cool. I'm not going to do that right now because I need to register for some stuff, it looks like. But yes, Tia.
So I know we're talking about apps, but this also gives the tool for websites, like building a website. What I'm thinking about right now is like Complex is doing a review on a new album, and they're like, oh, you can find the album on Spotify. Are they accessing that album via this?
They might be.
Like if it's embedded, or you know what I mean? Like is it the same thing, or is it?
Let's see. Like an embedded player in a website.
Yeah.
That is a little different. That's like an HTML specific thing where let's not look into it, but it's set up through their API for you to be able to go and put a piece of like Spotify information into your website. It's a little different than what we'll do with apps, where generally we'll pull down some information from Spotify and change it ourselves. This player is like someone creating a website saying, hey, like, go do the Spotify thing in this space, like kind of without any knowledge of how it works at all. Whereas in our apps, we'll be generally going to get information. There are things on like mobile apps that work this way, but generally our goal will be to perform a get or a post or whatever kind of request to get information back and then change it as we need to in order to use it. Whereas this is kind of like, I think I've used the term a couple times, like black box. This is just a black box of functionality where Complex said, we want to put the Spotify stuff in our page. Let's do that. Yeah.
The closest thing to a widget you might see in like iOS app development is probably like a Cocoa Box, which you can probably get to in like what, 5.
You'll have a lot of fun with that when you get there, in case you didn't hear Richard. Okay. So this is what we are doing. It's what we're going to be doing for a month. We're going to be able to make apps using stuff off the internet.
I'm sorry.
Keep going.
I'm really trying to understand like what data are we pulling. In your dog example, it was just the image, right? So for this example, is it just the song? We're not talking about the viewer, like we're not talking about the widget. We're talking about literally the data, the MP4, or I don't know what Apple is. Is it MP4? Whatever the information is for that song. Is that what we would be pulling? That's it. None of the background data, no imagery to go
Anything.
Okay.
I know that's not a good answer, but I don't really know how the Spotify API works. What I do know is that if you generally have a public API, they give you a quick start guide, which is like how do you get signed up. They give you a guide to the API, which tells you some of the things they'll let you do with it, like working with playlists. Cool, you can do some playlisty stuff. Let's see. How can I find out more about this? Oh, I'm in documentation now. That's great. Oh, look, they have documentation for iOS. Cool. Let's look at an iOS guide. Application lifecycle, making remote calls. Ew, that looks bad. How do remote calls work? I don't know. I don't know. But the way each of these things works, ooh, look at that. The way each of these the way a Spotify API or there's a Yelp API that's public or whatever it is first of all, whatever information they want to be public, because Spotify probably wants to protect their core businesses, their core business like information. And second of all, whatever information they tell you is available in their documentation. So each API could have a totally different set of information. Spotify's might be just they let you look up playlists. Like it doesn't look like there's that much going on here. But the Yelp API actually has a good amount of information. Come build with us using our REST API. We'll talk about REST a little later, to help connect consumers and great local businesses. Yelp Fusion. Unlock a wealth of content and data from over 50 million businesses. So the Yelp API is meant to, I don't know, help you look at information that they've probably mapped out over time. So they've got a whole bunch of what they call endpoints. An endpoint is a place that you can perform a request to, so a get, a post, a put, patch, delete, in order to get or modify some information. So it really depends on what the API is. There's no, until, I think the biggest skill we'll gain from this and later on units is reading documentation, reading about how they want you to use their stuff and what capabilities they've given you. So it totally depends every time. The simplest example I had was just the dog stuff. Dog. Let's see. There are other requests on this site. Let's look at the documentation. Aha. There is a place to do a request. Let's do it. Nice. It's got a list of all these different dogs. That's great. Not super helpful. That's okay though. Let's look at the top. Oh, there's another type of request for a random image. That's what we did before. Another request. And this is generally the form of documentation. It'll say some title for the request. It'll give you the request URL. And it'll try to describe what you should expect to get from a successful request. So this by breed request, blah, returns an array of all the images of a breed. Example, hound. So if I go and I perform a get request for this, gives me all the images for a hound. It's a lot of images. If you notice, in Postman, if I ever get to the bottom of it, these images were in a JSON object whose key, like always, was a string. But what format was the value of that messages? What format was the value for this key messages, Jason? So each of them is a JPEG that is in a string. But what's the actual format of the value? Let's just look at it, think about it like a dictionary. I know it's a little hard to see. It's an array of what? It's an array of strings. Cool. So this JSON object just sends back an array of strings for the key message, and then it also sends this status indicating a success or a failure if we screwed it up. Later this week, maybe even tomorrow, we're going to learn about how you can make this GET request or get back a JSON object and then convert it into a custom type that you create in Swift that allows you to then use it in your code. Because right now, all we've got is some kind of blob of stuff. A JSON object isn't really a type that we can use in Swift until we change it to a type that we want it to be. Sunny. Depends entirely on, again, what they want you to use it for. So this dog API we're using because it's completely open and because it's like just a good little tool. I don't think we'd build very much with it, but Yelp and Spotify both make you get tokens where they sign you up for their service, and they say, okay, anyone with this specific token is allowed to use our service, but they ultimately control your use of it. So they might say you're using it too much, we're going to block you based on what your token is. They might say you're using it incorrectly, we're going to cut off your service. So it depends on the maker of the API. Generally, if they want to control how you're using the API, they will not be open. This one's just like a toy, right? So it's just a little, I don't know, just made to be able to make some GET requests. Cool. How do you all feel about this? You can make stuff now. Make your own stuff.
I just want to see how we get
Okay, no. We're going to do that. Not today. Today is going to be kind of a fundamentals day. Let's take a break. And then after that break, I want you all to find 2 open APIs and make requests from them in Postman.
this is like the core of what
What you got?
Before I get my pants on it, you're kind of weird.
It was good. I did not really do anything. Yeah, it's good. Oh, no way. Tell me more. Say that again? A system? What's the system? Yeah. That's good. I like that. I think once you notice that you're getting bored or turned off, it helps you start experimenting. If you just got turned off to it, you would stop. But if you're able to notice, Oh, Richard.
That's what I was thinking. I was like, why isn't this working? The accessory with the shopping cart. I was like, I just not remembering what's in the shopping cart. And I'm like, oh, it's right. But the other one assessment, they're only working on one vehicle somewhere. Just use the object for the shopping cart. Always the same vehicle.
Yes.
So I mean, they set the model set the file for the like, oh, this is the shopping cart there. So it's like, fuck it, I'm sending the shopping cart to someone.
Oh, I should have recommended to make a game.
Yeah, so I ended up making a game with
Okay.
but I made the shopping cart a singleton. But I could have made the shopping cart as part of that game as well.
Right.
Yeah.
I mean, I like the one you suggested. I'm going to add you to this. So Unit 2 assessment is the crayons.
Grounds? I think I'd rather go crayons.
Oh, when you get time, I don't want to interrupt.
No, it's gonna.
I worked with some friends on creating this music app right here, where you can't play the music on it. And what I did was I worked on this, and the music works. I don't know if you can hear it. Yeah, each one, and I want to put that one, this code into this music app. But I got the code here, but it won't work. It's hard figuring it out. Later on, I'll show you what I did.
Okay.
See if you can try it.
Oh, it's the matter of figuring out what's happening when the
I
method is
pressed
being
that.
called. Yeah.
Because another thing was what I was thinking is that the iPhone, it already has a music library. So it's like, how can you call its music library in the app instead of like going to Spotify or something like that? So,
Which libraries are you looking at? Also, because it might also be a permissions thing, or it's like if you're not checking for permissions when that app is being in the how's it called? Information.plist. If those aren't set, it just won't work. So you have to request the permissions in information.plist to actually play them as well. I believe. So like also request to see if you have access to the music library. See if that might be it as well.
okay.
And then also just double check the methods to see if you're calling the same line.
Same.
Yeah.
Yeah, I'll show you.
Yeah.
Okay. All right. So let's talk a little bit about the nitty-gritty of the internet.
Can someone remind me what HTTP means? Hypertext transfer protocol. Great. That is a set of rules or a blueprint for how hypertext should be transferred. Does anyone know what hypertext is? Yeah. It's the way that information is sent around on the internet. Hypertext. Again, not important for us. The main important word here, that one, is a protocol for sending things around, for transferring things between computers on the internet. Ayla, what is a URL? Without putting it in my trying to Google it. Sophia. Ayla. Okay. I know the L. What's the L? No. It's not a language, so it's not yes L. Does anyone know what it is? The uniform resource locator. Can anyone give me an example of the URL? Allison. www.facebook.com. Let's look at this URL. The www stands for World Wide Web, right? We've seen that before. Does anyone know what this .com is? Sorry? Commercial? Actually, don't even know. What if it was .co or .uk? Does anyone know what we call that pattern on our URL? It's a specific type of domains. What? Jack? Yes. These are top level domains. Ariel, I think you're right. .com is a commercial site. .co, I don't know. .uk is probably for the United Kingdom. .us, top level domain they added. You might see like .co.uk or something like that. It's really just how it's implemented. I think that's so it's like, honestly, I have no idea. I think it's so that the shopping experience works well between America and the UK, but I don't know why it has that naming pattern. Siri?
No, they're actually not. That's a good question. So like Facebook.com, if we said facebook.com/UK, that's a different URL than facebook.com, right? So it's meant to, I think, have a British experience to it. I don't know, but its URL is different than the facebook.com that I might just enter. I have no idea why it's autofilling it to UK or why you're getting Australian things from Siri. It might be a settings thing. I don't think it has to do with the top level domain that Siri is looking at. It's probably, she's assuming based on your clearly Australian accent that you're Australian. Tia?
Sometimes also, my experience, one, I think of it like a area code. You travel outside the country and you go to Google, and it's not Google.com or Google.ca or Google.gp or whatever. In this case, that search is in it, it's going to give you results based on the country that you're in. But some websites aren't American based, so they're not going to give you .com from the jump. Like sometimes the dominating website is whatever country that company is based on.
I think that's on the browser side. Like your web browser knows to try to figure out where you are so it can give you the right top level domain when you look for something. Does anyone know what this whole system for the internet is called, of creating URLs? Yeah, give it a shot. I'll tell you, the acronym is one of the acronyms that we have not yet defined. It's not that. DNS. Someone tell me what they think DNS stands for? Eric. Domain name, something with an S. System? How do we feel about system? How do we feel about server? I don't know, I'm going to look it up. System? DNS. Server? Domain name system? Domain name server? Domain name servers? Ah, look at this conflicting information. What? Yeah. But when we talk about, technically when you talk about DNS, you mean the domain name server, which is not what I've written down, but that's an actual computer on the internet that goes and looks up this name and says where you should be looking for that site. So the domain name system is how we follow a specific format to then look up a domain name, which is what this is a domain name, on the domain name server. Does anyone want me to repeat that? Okay. You're going to see DNS referred to in two different ways. On the theoretical level, DNS, the domain name system, is the format of how you should create domain names. So there's a top level domain, there might be a subdomain, which is www in this case, and then some kind of domain name, maybe facebook.com. So Facebook on the top level domain com. That's the system. That's like the abstract level. The domain name server is where, when you type in a URL, the tubes of the internet, I don't know how it works, go ahead and they look up they go and they look for the actual information you're looking at. So the domain name server is an actual computer somewhere, or a series of computers, that lets you look up the URL to find out where you should be looking. Because a domain name is not the actual address of a computer. Domain name is like a fancy or like human readable way of doing things. It's saying, hey, I want to look for Facebook. The way Facebook is actually normally stored is not on a domain name. It's on something called an IP address. Every computer that's connected to the internet has an IP address. So I could look up in Google, what's my IP address? Go do that now. Are all of yours numbers separated by 3 decimals? So your internet-connected device has an IP address. Let's check out Facebook's IP address. Facebook IP address. Ooh, it looks like they have a whole bunch of IP addresses. So if you want to block access to Facebook from your home network, restrict the entire IP ranges. You can block IP addresses. You can block these numbers, these internet-connected devices. That's cool. So a domain name is just a quick and dirty way to refer to an IP address. Every domain name refers to a specific place in the internet, and those specific places are ultimately named by their IP address. Adam. Why would Facebook have more than one? What are some thoughts you have? Okay. How many users does Facebook have? So, let's say Facebook has 1 billion users. That's 1 billion. A lot of zeros. They only have one IP address. What's that?
It was just one. They do a global program, so they spread IP addresses out across the world so that you can access IP addresses that are like one. And I was talking about like how the experience there, instead of everybody trying to access the same IP address, California, on Facebook, India, access whichever one is closest. You know what I'm saying? We're thinking of servers, we're thinking of cloud, that type of
So, you might want it for convenience of location. You might want it for, what else was in there?
Wait, what the first thing did you say?
So you might want it for convenience based on location. You might want it for what else? Stop overload. Yeah.
Too many requests to the same server would probably too much.
Yes, there's a big problem in computing called concurrency. Crystal, what do you think?
Facebook around those. So if you're somewhere else, Facebook.com or whatever it is in that language, would possibly be the same. It would be the same Facebook that you're on. And I think it's just because Facebook is different. So when Facebook.com is not the same thing in Japan or anywhere. That's the same.
Units, languages? Eric?
I was thinking if, like, Facebook wants to be consistent, so it's just my guess, if we want to keep address those down, there'll be other ways to access Facebook.
Yeah. So deal with that overload. The biggest reason here is that if a billion people are all looking at the same thing at once, it's not going to be able to handle all those requests. And that's because the internet works on the client-server model. Anyone ever worked in food service? Got really fat from it? Nice. I got really fat from other things. Sorry, this is not eating. Remember a server? Yeah. Okay. Tell me about your relationship with your clients. Okay. Tell me about the physical interactions and things that you would do with your clients.
The first thing I would do is greet them,
Okay.
and then I would mention the specials, and then I'd ask them if they would like anything to start with, and then take that order, and then their drink order, and then ask them if they were ready to order their meal or not. If they weren't, then I'd come back. I'd go and get like their drinks, and then come back and ask them if they were ready, and then take their order. Any other questions?
I think that was it. It's a pretty good explanation. So they would ask for stuff, and then you would give them stuff.
What was that?
But there is a bug in there.
Yeah, they would send a get request and
There is a bug in there.
What is more than just a wow?
oh,
Wait, what's going on?
I don't know. Don't listen to that. I was gonna say are more than money. It looks like it's Good plan.
So, in a restaurant, a client says to the server, I need this. The server goes and gets that information. The server then, or food is the thing. The server then brings that back. That's the same relationship on the internet. So, when I'm in a web browser, or if I'm in an app that's connected to the internet, the client is that app or that browser. And it says, I need some information. It goes and it performs a request, like we did get request just before. Performs a request to a server. A server goes and looks up some information based on that request. So the server might go to a database and say, here are all the dogs I have. Or it might say, here's a playlist. The server then sends a response to the client. So clients are pretty, clients might be grateful or ungrateful, but they always get a response from the server. Those responses, when made on the internet, have one of these 5 codes, like we're looking at. A 1x is information about the status of the request. So it might be the server coming back to say, hey, like we're still working on it. 200 is bringing back something, a successful response, bringing back something successfully. 300 might be like, we don't have that on the menu, do you want to try something else, move location? A 400 response is a client requested something that the server said, this is an improper format. So if you go to a seafood restaurant, you order a hamburger, it's not the right request. Last is a 500 error, which is the server saying back to a client after a request, we couldn't do that. We don't know how to do that. We don't code that. You're going to see this one and this one the most. You might also see this one sometimes. You're going to see success and failure methods, success and failure messages. And generally, when the failure occurs, it's because your request was incorrect. Sunny.
So an IP address is like the pathway between the client and the server?
The IP address is where the server actually is. So it's where any computer on the internet is. So the client itself has an IP address, and the server itself has an IP address.
So Facebook having multiple IP addresses, does it go back to the same server or goes back to different servers?
No idea. It's handled by the domain name server, not by data. It's a very good question. It's a really good question. Should we find out more? How does DNS handle multiple IP addresses? Can DNS have multiple IP addresses? DNS can hold multiple records for the same domain. DNS can return the list of IP addresses. When a web browser requests a website, it will try these websites one by one until it gets a response. So on the domain name server, when you go to facebook.com, it will start trying each IP address that's listed for it until it gets a response. How to configure DNS round-robin load balancing for high. DigitalOcean, hi. A good method to geographically distribute your application by taking advantage of your provider's global presence is to use and manage DNS responses. Unless you are willing to spend a little fortune on hardware and infrastructure costs, none of this really applies to us. But I guess the answer is if it has multiple IP addresses on file for facebook.com, it's going to try them until it gets a successful response from that address. So it's not going to look at multiple computers once one computer says, I'll take care of it. Multiple servers won't come over at once if you just ask, can anyone help me? It's going to be one person. What? So again, I want to stress, every internet-connected device, every computer that uses the internet has an IP address. Every single one. Cool. TCP/IP, we talked about a little bit on Friday. You'll never explicitly be using this. It is the set of protocols that let you use the internet. Does anyone remember what they are?
We looked at it in the Postman.
No, just what do these acronyms mean? Transmission Control Protocol. We got the IP here. How do you feel about that? You do? That's great. Okay. TCP/IP again, you do not use, your computer uses it. It's how your computer goes ahead and says, on this interconnected billions of computers, please go find me some information. You yourself never need to go ahead and use that. It is what underlies all of that. There's one more term here. Has anyone ever heard of an API?
Yes.
I remember on day one, Jack was really excited about APIs. Jack, what does API stand for? Application Programming Interface. I'm going to take a picture of all of these terms. These are the words you will need for the next month. A whole month. What are some questions you have about those words?
Would there ever be like an instance where we have to like specifically like say all of those words?
I would say you won't have to say all of them, but you will be using each individual one very often. Very good question. I know it was pretty much a, is this on the test kind of question, but it's a very good question.
URI?
What's URI? I don't know. I forgot what the I is. Identifier? That sounds good. Identifier. So URL is the actual location. The URI is a path to any file in the file system. I know this is a bunch of mumbo jumbo right now. It's okay though. Has anyone used an API today? Sam, have you used an API today? The dog API? And Yelp, you said? Oh, the dog one, okay. That's cool. Does anyone else? Sorry. You probably use them all the time? Oh, okay. All the time. Why do you think you've used them all the time? Because you use the internet. Interesting. You need to get data. Interesting. They're using Swift? Tell me about that.
Like sorted by.
It's an API? Whoa. Sorted by Swift. API.
APIs are also kind of like closures.
APIs are kind of like closures. Tell me more.
I can go on and on. Do you want to just switch roles?
Yes, that'd be great. Don't tease me like that. So an API, roughly, is a way of linking between you, the client, or your application as a client, and some data that you want to change or get. Typically, when we talk about APIs in the world of iOS, we're talking about ways of getting data from the internet. But it's a much, much more broad thing. Has anyone created their own API recently? Alex?
Like anytime that we create our own type, we add any methods, those are APIs.
When you create your own type and you add any methods, that's, sure, I accept that. That's cool. So like, when did you do that? Can you give me an example?
Like when we wanted to filter something.
When you wanted to filter something. Like what? Tell me about what you made.
Sorry.
Tell me something you made.
I would like when in my model to say I wanted to just generate like the red color. Like the flow for the red.
Yeah.
So I created a property, sorry, a method that handled that and returned me a CG flow for the red value.
Cool. So that was in the color guessing app. RGB, color guessing. Eric M. Can you tell me about an API you created? Something that linked to your application and gave it or changed some data based on communication between it and your app. You've definitely done it. Did you make the tic-tac-toe game? Okay. How did you handle information in your tic-tac-toe game? Like if someone won, or what the current state of the game is, or whose turn it is, or stuff like that. A bunch of if statements? Oh. What was the function of those if statements in the end? What about on the highest level? What did those if statements handle? What were they for? What were you trying to determine? It was the same. Yes. So how would you describe that if there was someone who didn't know code? What was your code doing? Comparing what? To figure out what? Okay, cool. So let's call that your game brain in tic-tac-toe. That was an API. That was something where your application said, go get me some information, or let me change that information. And then something that handled data said, okay. Bless you. made APIs. All an API does is allow you to get or change data from somewhere. Do you have a question, Steve? Adam.
Are there companies that do like sell their APIs?
Say that one more time. I'm sorry.
Are there companies that sell their APIs? The way you find out source with that in the future?
Yeah. Are there companies that sell their APIs? I bet you there's a whole acronym for this. Hang on one sec. What is it called when you sell an API? What is an API in business terms? Oh, an API specifies how software components should interact. They're not giving me my answer. But yes, companies create products out of APIs. You sometimes see that referred to as SaaS, software as a service. You might see other APIs referred to as BaaS, backend as a service. This is calling it backup, but no. BaaS. BaaS. Backend as a service. We're going to work with a backend as a service called Firebase later on. But it's a bunch of APIs put together that you either pay for, or luckily for us, Firebase can be free. That is a model for providing web app and mobile app developers with a way to link their applications to back-end cloud storage and APIs. Ooh. So these are whole.
AWS like a BaaS?
AWS is a lot of things. It's a SaaS, it's a BaaS, it's a SaaS.
Grass.
AWS has like a ton of different services actually. Those would all probably fall under those categories. So you have made APIs before. The majority of the APIs we're going to use are from the internet. Eventually you're going to create your own internet APIs. Are you all excited about this? You're going to be able to create your own apps. Like top to bottom, no one else would ever need to touch them if you didn't want them to. You could change the information on the fly in Firebase, which is still some ways off, but I want you to be pumped about it. So now I want you all to take 6 minutes, visit my friend here. So there's this application called Google. Let's go to google.com. Okay. Find 2 open APIs, so 2 APIs that you can make requests to, and make requests to them in Postman. And then we'll report back in. So literally just Google what are some open APIs and see if you find anything interesting. Hi. What's an API you found? Mm-hmm. What is an SDK? It's a good question.
Well, the reason why I asked the question is because I'm on Rapid API, and a lot of the APIs installed.
What does SDK stand for? Okay. A software development kit is a kit that they'll provide you for software development. So if you're trying to use an API, sometimes you don't have to go ahead and try to access the information individually, but instead, they might give you some tools to be able to go and access their information. Firebase has an SDK so that you don't have to go to a website every time you want to use a Firebase option, but instead you use their tools and you say, hey, I want to go look up the thingy I made here. Can you go get that for me? So they're trying to make your job easier. That's actually really good. Let's add that to my list of developer damn it. Sorry, hold on. Let's do that over here. Termin programmer. Yay! The internet. I think everyone should have access to this. Nope. All right. Well, I will add you all to this eventually. The internet. What are some big important topics we should know about the internet, just based on what we talked about today? I'll give you one. One is an API. Shout out some other terms that you might have heard of today. Domain. IP address. Jocelyn, what's something else we've talked about today? Say that a little louder. DNS. Great. Let's put that right there. HTML. Yeah. Mark up, mark up. It's good that I kept using the wrong word. HTML, hypertext markup language. URL. Carrie, what's another thing we talked about today? Got it. What else? Error codes. I'm going to say the second biggest one to think about is client-server model. So I'm keeping a list of all these topics that I think would be good to know about. It would be good to know them now, but when do you also think it will be good to know about them? What is your goal after completing pursuit? Getting a job, that's right. So I'm keeping a running list of things that I think would be important for you all to know. I hope you'll do something similar. All right, what's a cool API that someone found? Rob, NASA API. That's cool. Have you tried using it? All right. Most developers get started with API.NET, wish to leverage NASA data in their applications and services, and this is encouraged. There are developers that have existing APIs that they may wish to contribute to the NASA API. Below describes 2 paths on how to use it, as well as contribute. Ooh. Ew. So NASA will let you go and look at their images. That's cool. Then it'll let you go and find out some more information. Interesting. They've built into their site this little thing that I could type in. Console.log this. Oh, all right. They'll let you look at stuff. Did you figure out how to use it? I think you have to sign up. Did anyone find anything that you were able to get information from right here, right now? Angela? What? Pokemon API? Pokemon API. All the data you'll ever need in one place.
You want to start with this one?
What? What?
This one's pretty,
I don't know.
I think it's a good one.
We're just playing with APIs. If we put in Postman, we can do this. I'm sorry. Whoa. We looked up Ditto. Ditto's got some abilities in an array.
It's every ability, like EV, ID spreads, like alternate arts, like bright arts, and everything.
It's good. I don't know anything about Pokemon, so this is really helpful. I can look up a whole bunch of Pokemon stuff. They gave us an example. You'll see this very often. For an open API, they'll give you an example on how to use it because they want to make it very clear so that you then don't contact them. They have no interest in being contacted. If something goes wrong, they generally will not respond to you for a very long time. And so that means it falls to you to figure out how to use the API, which is nice because they say check out the docs. pokeapi.co docs. This is a consumption-only API. Only the HTTP GET method is available on resources. So you can only get information. No authentication is required to access this API, and all resources are fully open and available. Since the move to static hosting, blah, 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 blah. Oh, actually, no. Since the move to static hosting in November 2018, rate limiting has been changed to a fixed limit of 100 API requests per IP address per minute. What do y'all think that means? Iram, if you have to give that a try, what do you think rate limiting has been changed to a fixed limit of 100 API requests per IP address per minute means? Yeah. So you can only make 100 API requests for each IP address you have per minute. How many IP addresses do you likely have, Michelle? Yeah, you likely only have one IP address. So if you go to Postman, you keep hitting send. Let's see if I can hit 100. There's probably a quicker way to do this. Oh, fuck you, Postman. I'm gonna beat that 100. Let's look up a better way to do this. How to send a request multiple times. Yes. Running multiple iterations. Postman Learning Center. Whoa, there's documentation on Postman. Neat. Debugging with multiple iterations. Whoa. Working with multiple iterations can become tedious when switching between them. When the run is finished or stopped, you can open up the run command. Let's see. Runner. Collection runner. I don't know. Let's not do this right now. What? Good, let's do it later. So this is a consumption-only API. So only get methods available on the Poke API. There's all this free stuff. There's a fair use policy. Huh. Okay. It's primarily an educational tool, and we will not tolerate denial of service attacks preventing people from learning. There are rules with how to use it. This is generally a good rule to follow. Be nice and friendly to your fellow Poke API developers. Cool, I like this one. It's another API people found. You might find stuff like a gambling odds API. Whoa. Get sports odds data for loads of sports from US, UK, and Aussie bookmakers. Look, they give you an example of what a response might look like. So one for slot machines. I don't know. Yeah, I don't think slot machines are that dynamic. I don't think this is going to work. Yeah. Don't worry about that. But they show us what an example response might look like. There's a success key that's true. There's something called data, which is an array of objects. Neat. I got this response from performing a get on a URL. That URL I needed an API key for, so it's not going to work. But look, they're API docs. How to get started. So there's a format to most APIs. They will generally show you a sample of how they work. They'll give you a getting started guide, and they will then give you all the documentation on how to use them. Get sports. There's a URI right there. That's a URI for looking at their API for a sport. Returns a list of in-season sports objects. Cool. This API key thing, that's what you have to sign up for. So it's not an open API. It's not for anyone to use. What's one more API before we take a break? Did anyone find anything particularly stupid? I'm sorry? Cat Facts API. It's not stupid at all. Okay. This API provides endpoints. Oh, wow. Oh, it's a Swagger API. That's so cute. Sorry, this is like a very old style way of making an API. This API provides endpoints to get random cat facts. Ooh, there's docs. catfacts.ninja/breeds. Let's go ahead and get that information. Ooh, so I got back this thing, and I got some data. Looks like the data usually shows some information for me. Here's something cool you can do. For most GET requests that you get back a JSON object, if you are using Chrome, I don't really use Safari, so I don't know how it works, but if you're using Chrome, you can just perform that GET request in the browser itself. Postman will let you do a whole ton of other things, but if you just want to see the JSON, and you're looking on the web, you can just paste that in there. It's probably not going to look as pretty for you because I'm using a plugin called JSON Formatter. So if you want it to look all like this as opposed to one straight line, let's turn it off. La. Ew. Look at that, it's nasty. It looks so much better now that I'm using JSON formatting. Cool. Ew. Yay. Ew. Yay. So that's called JSON formatter. There's also one called JSON viewer, I think. Chrome extensions are open source, so it kind of doesn't matter. Let's take a break. Look at all these APIs. Hi, Kimball.
What's up, Kimball?
Echo? You get it. Okay. So, you can look at JSON through the internet. You can look at JSON in Postman. There's one even older way of looking at JSON or making requests to the internet called curl. Has anyone heard of curl before? Curl. C-U-R-L. Let's find out more about curl. Curl is used in command lines or scripts to transfer data. It's also used in cars, television sets, routers, printers, audio. Oh, crap. It's used all over. Curl is a computer software project providing a library and command line tools for transferring data but using various protocols. It stands for client URL. Neat. Let's see what it does. Oh, let's clear this out. Curl And then here's that website of cat facts we were just looking at. Oh, so it gets me that entire response. Nice. That's cool. So everything I can do in my browser, I can do in Postman, I could do in curl. Neat. Those are all the things I have for you today. Because today's lab is going to be a scavenger hunt, where you try to find each error code. Would you like me to walk through it? So here's the dog again. Today's lab is fun because you will not be coding anything, and you will not be looking at code really, but you'll be doing a whole bunch of things that interact with code. Part one, you're going to use Postman to look for the following HTTP codes: a success rate, a page moved, a bunch of 400s, bad requests. Look up what 418 is. Actually, look up all of these. And then 500 is server error. For each of them, you're going to write the questions below. The website, which generated the HTTP status code. A description. I don't love these. A description of what the status code means. And if an app you were writing encountered the status code, what would you do, if anything, to resolve these issues? In the second part, you're going to look for open APIs that will give you the appropriate JSON. You're going to try to get a JSON that gives you all of this information. A cat fact, 150 random users, current stock price of Microsoft. Ooh, there's an IEX API? What is that? The Investors Exchange API. It's a set of services offered by the Investors Exchange. You can look up prices or stocks. I don't really know anything about stocks, so I'll just call them stocks. You can look up prices for stocks using an API that they created, the Investors Exchange. If you go to endpoints, that's typically where you will see, it's typically where you'll see what address to look at. So when we refer to an API, looking at a URL on an API is often referred to as hitting an API's endpoint. So it looks like there's an API for iextrading.com. I don't know, .com. Do they have some kind of word wrap? That's funny. Do you guys see that? So this site has something in their HTML that automatically adds a line whenever it wraps text, but I don't think they want that. Anyway, that was funny to me. I'm just having fun up here. An endpoint is typically the web address, the URL that you will go to hit an API, so to speak. That's what we mean when we refer to endpoints. So that's your lab for today. Go find these things. Before we do that, do you have any questions? Phoenix. Can you send it to me and let's take a look? Slack it to me. Jason. Such a good question. Forget Olympia, what do you think? Going forward, would you like them to fork labs or to create a pull request inside the lab? Or so fork it? Don't fork it. Create your own branch? All right. Create your own branch. Phoenix, did you send it to me? All right, tell me which one. Let's take a look. Which one didn't work well? Any of them. Let's try cryptocurrency. Bitcoin charts. Bitcoin charts. Trade history. HTTPS. I'm sorry. There was an error. No. Maybe it wasn't working. Did you get an error? Or let's look at Coinbase. I think they're still in business. Coinbase Connect. No. Coinbase Commerce. No. Too much. Don't want to think about it. Let's look at books. The Bhagavad Gita. Oh no. Requires off. Oh, look at that. It tells me everything I need to know. Does it require off? Oh, great. Okay. The British National Bibliography. I don't know how to use this. Give me an easy one. Come on, guys. Goodreads. Goodreads API. Cool. Oh, I don't want to sign in. Leave me alone. Which one was that? Let's try this guy. Could you Slack me that link if you happen to have it? Invalid OAuth request. Oh no, I'm inauthenticated. Look, I got a status, 401, unauthorized. Similar to 403, forbidden, but specifically for use when authentication is possible but has failed or not yet been set up. Huh. I've got these status codes nowhere. I'm sorry. Let's look at it together later. What are some other questions you have? We've learned about error codes, we've learned about URLs, we've learned about APIs, we've learned about the protocols that run the internet, we've learned about web addresses and their aliases. It's an important term to know. An IP address's alias is its domain name. Alias, right? Like spy has an alias. Ian.
You have the 401 error code there. That, what do you look for in the lab? Copy that next to the lab, just copy the guy that wrote that error code, or
Tell us the website, so the URL, a description of what the status code means, which I guess you could probably just steal from Postman. No, do not steal it from Postman. Put it into your own words to describe what you've encountered. And if an app you were writing encountered this status code, what would you do, if anything, to resolve any issues? Ooh. So you tell me what you would do.
the website generated the error code, literally the API address.
Yep, just the URL.
You don't want goodreads.com because it's not that whole.
Yeah, I want to know the actual endpoint you're hitting. Sunny. Why not? Why? Let me put it in Slack. Oh, yeah. Okay. I can change that. Mm-hmm. That rule, master. And Olympia. Mm-mm.